Now we would like to analyze the effects of a change in the interest rate. Suppose that interest rates were to go up by, so currently the required rate of return is 8%. So let's say that the interest rates went up by 10 basis points. Okay, let's write it down here. Suppose that you wake up, you go to work, and you realize that suppose that interest rates went up by 10 basis points. 10 basis points is just 0.1%. So because interest rates went up by 0.1%, the new rate is 8.10%. Does that make sense? 8.10%. And the question then is, what is the value of the bond? Well, you know what? Because pretty much we have all the other numbers, let's just calculate the value of the bond directly using the formulas that we learned how to use. So present value function. So the new rate is this number divided by 2 because it pays semi-annual coupon. Number of periods is 8, comma. The payments are still $50, comma. Because it's a 10% coupon bond, right? So it has to be $50. And finally, the face value is $1,000. All right, so if interest rates were to go up from 8% to 8.10%, the value of the bond would go slightly down. Do you guys see that? It used to be $1,067. Now it's $1,063, which is consistent with what we did earlier. Earlier, remember when we analyzed the graph, we realized that when interest rates go up, the value of the bond goes down. So this bond has the following sensitivity. When interest rates goes up by a tiny bit fraction, 10 basis points is extremely small change in interest rates. It's equal to 0.1% increase in interest rates. Suddenly, the value of the bond goes down by $4 in a sense, right? So how does duration help us make that calculation in a different way? So now that we know what the duration value came out as, we can use the following formula. I'm going to use my pencil for that. Let me write the duration approximation formula. So duration, formula to approximate the change in value of a bond. And the formula is as follows. The change in the price of a bond divided by the original given price is simply equal to minus modified duration times the change in the interest rates. Let's put the letter R. Here you might wonder, what does this represent? Modified duration is simply duration divided by 1 plus R. But in our case, because it's semi-annual, I need to divide it by 2. That's pretty much it. So let's just go ahead and create here a space to make that calculation. So this, and in fact, one other thing we can do is we can even take that price to the right-hand side. So in a sense, so the formula we will get will be the following. So change in price of the bond, the value of the bond, if you want to call it that way, change in value of bond is going to be the following. So it will be equal to the product of 3 things. It will be based on the original value, the price of the bond. It will be based on the modified duration, and then it will be based on change in R. Well, the change in R, we know what it is. It went up by 0.1%, so 0.1%. The modified duration is equal to, it is just the duration, this number, divided by 1 plus the interest rate divided by 2. So the interest rate is, well, at that step you can even take an approximation. You don't have to use the new level. The old level would be good, which is just 4%, right? So there you go, close the parenthesis. So that's the modified duration. And finally, the price is the original starting price, which was this number, right? So this is equal to that number over here. Now, I might want to just, so there you go. So now we can create the value. So the value would be, let's just put it right here. So the value, the desired answer will be equal to the product of those three numbers, but with a minus sign in front. So it is that number. Well, that number already has a minus in it, so I don't have to put an extra minus. So that number times modified duration times the change in R. All right, so it tells us, the formula tells us that if interest rates were to go up by 0.10%, this number, the value of the bond will go down by $3.51. Let's see if that changes close to that. So change, just to confirm or verify the result is true, in value. Let's see if that's correct. So this is equal to, so the new value minus the old value, and press enter. $3.50. Do you guys see how close we are? $3.50. So that's why I called it as a approximation formula. This doesn't exactly give us the formula, so maybe we can put an approximation sign here. So let me put an approximate sign instead of an equal sign. But that's a very effective way of figuring out the new price, right? So as a result, if you want to find the new value of the bond, that's simply equal to the old value, which was this number. If you guys want, let's just put a minus sign in front of it. There you go. And we know that we need to add this number to it. So because we know that the value of the bond is going down. There you go, $1,063.82, which is a very good approximation. This is the true value, true. This one is an approximate value, approximate. Now, we didn't get the exact same value for the following reason. It turns out that we treated this downward sloping curve as a line, straight line. So if you just treat it as a straight line, that's the result you get. In reality, this is not a straight line. It is a curved line, but unfortunately, it's very hard to see the curvature. The curvature is very small. So in upcoming videos, when we study convexity, which is another feature of a bond, so rather than duration, on top of duration, if we add convexity, suddenly the error term will be significantly smaller. And so that will give us a much better approximation. But based on what we did so far, we learned how to calculate the interest rate sensitivity of bonds, bond values. Bonds are very sensitive to changes in interest rates, and we are able to follow that up using this duration approximation formula. Now, in the next example, what we will do is we will construct a portfolio consisting of a bunch of bonds, and by changing the interest rate, we will be able to change the whole value, find the updated value of the whole portfolio. So looking forward to see you guys in that lecture.